Hello everyone, in this tutorial, we will improve the vehicle to avoid driving on the sidewalk by implement the float value on the grid cell so the vehicle can evaluate road location, the sidewalk, and the obstacle. This makes the vehicle have better navigation, and we will implement more improvement in this tutorial. First, we download this file. I will put the link in the description. And in this, we have vehicle AI BP library.h and .cpp. Extract it. Copy vehicle AI BP library.h. Go to our project graphic tutorial and go to plugin vehicle AI source vehicle AI public. Delete this vehicle AI BP library.h and paste .h. Copy .cpp. Go to our plugin and go to private. Delete this vehicle AI BP library.cpp and paste this instead. Next, we delete binary and intermediate. Delete.vs binary derived data intermediate save .vs config graphic tutorial.sln, and then we can generate Visual Studio project file. Open graphic tutorial.sln. Go to plugin, vehicle AI source, vehicle AI, and open this vehicle AI BP library. And make some change to this A-star pathfinding algorithm by include this array of float. So this grid we can set this to float, and this value, if it is greater or equal to 1, we use this grid value, and if it is less than this, the scale value is 1 and we multiply with this grid value. And another change is I add this bubble sort algorithm, so we will use this algorithm in this tutorial. Let's run this. Go to vehicle AI component. Now we have some error with the grid. When we compile, we have this error because we change this grid to float. So this variable need to be float. Change variable type to float. And we compile again. Go to this error. We need to set array element. And this index. These two items. Convert this boolean to float and size to fit. Delete. Next, compile. Return grid float. And we don't have any error. Try play this. And it is still working. You can enable debug grid. Go to display trace and we lab this like display trace. Right click and collab node. Name it to set grid cell value. Add output. Execution. Then open it. This debug grid. We need to change it. So delete this. And this is the point. Add new local value is grid value. Float. Get grid value. Map. Range claim. From 0 to 2. And out is 120 to 0. Because we want the color from green to red. And HSV to RGB. S is 1, V 1, and A is 1. And connect to line color. And if it's true. Next we disconnect this and collapse this as a function. Name it to get grid cell value from road. And add input. 3 input. First is grid location. And vector. High index. Integer. With index. Integer. And output is grid value. Float. And set grid value. Delete this. And use this grid value to set array. Next this. Get row location. Get high index. Get width index. And open this. This start and add is grid location. And this at we get this location, grid location, create a sequence, create a branch, add local variable is local grid value, and set this to 2 if we overlap the sphere, and if it fall, we do the line trace. Line trace for objects. Copy this grid location, add it with Z is 200, start location, and Z is minus 1000, add location, and this object type we make array, it is var static, and break the hit result. This hit actor get tag, check if we have any hit location, and get the row equal to row actor. We add a branch. If this true, and set local grid value to 0. If it false, the local grid value is 1. And this one is false. We can comment on this, press C, select all of it and press C. 0, it means it is empty space on the road. 1, empty space of the road. It can be sidewalk. And 2 is obstacle. Now we can return this local grid value. File and save. We can move this here. Let's play. We set this location. Before, when this location is empty, the vehicle will use this path. But now we will make this vehicle use the road location. And you can see this is yellow. The value is 1. So it choose green. The value is 0 instead of this location. Go to BP fly pound. And we will delete this show mouse cursor because we can move fly around without using the right mouse. And the right mouse used only to turn the camera. Let's connect this directly and delete this. The same with IA down and this IA up. Compile and save. We can close this BP fly pound. Let's move this vehicle here. And if we play and set the location here, the vehicle will reverse because it don't have enough space for turning. So we need to prioritize on the K-turn. Go to vehicle AI component. The tool can perform turn maneuver. Let's disconnect this sequence and move this spring forward. This sequence connect to this and this. Then connect to can perform Thai K-turn. And if this fall, we connect to this branch. And we don't need to avoiding obstacle to do the Thai K-turn. And connect this overlap front to condition. Compile and let's try this again. When we set this location, now the vehicle will perform the Thai K-turn at this location. Go to vehicle AI, event graph. This can reach grid edge. We want to check who point at the edge of the grid. So we need to delete this. Edge is less or equal to 1. And this y is greater or equal to this grid width subtract with 2. And connect this or this edge less or equal to 1. Grid height subtract with 2. And this y greater or equal to this grid height subtract with 2. This location and connect to all. Go to check target arrival and this default spline is valid. Check if it is valid. Next, we will improve the function find nearest location. Rename it to find nearest grid location. Open it. We see the local variable. We have this local variable. Add another variable is index and set it to integer. Boolean is initialize Boolean because we don't want to set the index is 0 and set this nearest index. We will check if it is initialized. And we delete this. Let's set this to index. Get grid. Get a reference. Get index. And not equal to 2 because 2 is the obstacle grid location. We add a branch if it's true. So comment on this. Grid location doesn't have obstacle. And this distance, we can get location from the input. Less than this distance or Boolean next to this branch. Is initialized, not. If it is not initialized, we set this nearest index. If this true, and this is the index, nearest index. After that, we return this nearest index and this array to get this nearest index location. Compile. And we can see this function we use here, find nearest grid location. This find nearest grid location, we can duplicate and rename to find nearest location for general use. We remove this grid location. This check. Delete this. And return node. We change this start index to nearest index. And this location to nearest location. Now this function we can use in other function that is more general without the grid. We can close it and compile. There are some errors when we set this nearest index. So we can change this name to local nearest index path, and we don't have any error. Delete this and go to speed trace grid. We want the previous path location to influence the grid value. So we have the continuity of the path for avoiding the obstacle. Move this a little bit and create a sequence. Create a branch. We can collapse this node and rename it to set path location for grid cell. Add this output, execution, then open this node. Get free path location is not empty. Create a branch. If it's true, we call find nearest location, and the array is this previous path location. Get vehicle actor. Get actor location. We don't want the previous path that the vehicle already passed influence the grid value, so we need to remove from the array, or we only add the path that is in front of the vehicle. And find the distance to this actor location greater or equal to grid gap and multiply with 1 and create a branch. If this true, we get path to final target and set it to path location. Add another variable. Name is path locations. Vector array and set to this. When it is true, call for loop. The first index is this nearest index, and the last index is previous path location plus index. Next, we get this path location and add it. Copy this previous path location. Get this index. We can debug this path location. So add a variable debug real path. Boolean, single, create a branch, complete, get add location for each loop, draw, debug, clear. Radius is 25, blue color, duration 3, and thickness is 2. If this previous path location is false, we can set this path to final target location. It's not empty. Set it when it is not empty. Compile and save. Back to set grid cell value. Add a new function. Name it get grid cell value from path. Add input, array location, vector, and array location is single value this is float and we return grid value. And disconnect this. First, we can find nearest location and get location. Find the distance from this location. Need to change this output is nearest location. Get location. Lamp float from 0 to get grid gap. Multiply with grid width max grid height. Divide by 2. And connect to this lamp. And we add it with grid gap multiply by 4. Add local variable is distance factor. Load and set it this value we divide, not add, divide with this grid gap. But we get this distance factor with the nearest location of the path, and we create a branch. We have the input name is value, is the previous grid value that we need to adjust. Check if it is equal to 2. If it equal to 2, we don't adjust it because it is the obstacle grid, so return this value. And if it is equal to 1, so we need to adjust it. Set distance factor, get distance factor, power by 2, multiply with 0.5, and clamp float 0.5 meg. Next we get the value, multiply with this distance factor, and clamp this 0 to 2 because the meg value is 2. Return node, return this value. If it falls, set distance factor, get distance factor, power by 2, clamp float 0 to 1, and this is the distance factor, and we return by multiply with this new distance factor. Now we can compile and save. Go to set grid cell value or get grid cell value from path. So this grid value is the value we need to have path location as the input array, and this row location as the location, and this is the grid value. And this debug previous path, we can enable it. Can close all of this, and we don't need this function should spawn new path. Compile, search for should spawn new path, delete this function. Because now we have the better system, we don't need to check should spawn path before we spawn. And check target arrival, we don't need to clear this previous path location because we need it to influence our grid value. So delete it. I made a mistake in this find nearest location. After we set this distance, we need to set this is initialized. Is initialized and set it to true. Copy this. The same with find nearest grid location. We need to set is initialized to true. This grid gap. Let's multiply this by 4 and convert to float first and connect with this. We have this problem in this value. We need to add with distance factor, not multiply. File and save. And close all of this. Go to our project. Let's run this. And now it is working. And you can see this previous path influence our grid cell value. Go to this field trace and disable this debug previous path. Let's add a new function. This function name is get grid cell value near obstacle. So we want to adjust the grid cell value when that location is near the obstacle. Call a speed trace by channel. Add input grid location vector value and float. Compile. Output is grid value and change to float. This grid location start and add location. Get grid gap to float to radius and floor actors to add a branch if it's true. Add a local variable. Name is local grid value to float. Set this if it's true and if it's false. Get input value. Multiply with 1.5. Clamp. Float. And min is 0. Max is value equal to 2 if it is the obstacle location. We set it to 2, and if it is not, we don't want to set it to obstacle location. We want to increase the value to the max is 1.8 and connect to local grid value. Copy this, and if it falls, we use the value as the local grid value and return. Return this local grid value. Go to this set grid cell value. Another step, we get grid cell near obstacle and copy this row location, and this is the value. Return this. Compile. We can play test it. Now you can see some of the location here have the orange color because it is near this obstacle. The same this location. Next, we want to improve this find base target location function. So we can add a new function. This name is calculate at points length. Add input is at points point array. For each loop, get path points, get a reference, this index, and this next index, add with 1. This path point is valid index, and this next index, add a branch, loop body, call grid point to location, copy, distance, add a local variable, total distance, get total distance, add it with this distance, and set to total distance when this value is valid. Next, we return. And at output, length to single float. And this is the total distance. Compare. Go to find base target location, rename it to find candidate target location. So open this function. We can move this this grid location after this. This local variable, add another variable is distance target on spline, and this float that this get default spline, get spline, get distance along spline at location, and this is world coordinate, this grid location, copy this, get vehicle actor, get actor location, we get this distance, subtract with this, and we clamp this float. Min is 0, make distance start to target multiply with square root of 2. It is more than 2, so add it with max, set it to max, and set to distance target on spline. Next, we change this distance start to target to distance target on spline. We use distance target on spline to make sure that the vehicle progress forward on the spline. And we can remove this spline loop because now we don't have the loop. And we change this value, this subtract, let's multiply, get grid, get reference, get array index, and map range, clamp, range from 0 to 2, and we reverse it from 2 to 0, multiply with this score. We want the grid value to influence the decision of setting this target location. So comment on this grid location is on the road. We want the grid location that is on the road to have the higher score to this. Next, we add variable. This variable name is scores array. And another variable is in this. Integer and this get base location index, we can delete this. We need to add this first. Add the score to array. And add this index. Get array index. And connect this. We can delete this and output return node. Add another output boolean. Name it to test target location. Compile. Save. When this complete, let's call bubble sort. Collab node. Name it to sort indices by high score. And input execution execute, and this output then open. We get score indices. Go to these local variables. We can remove this base location index, base location, and add some variable is candidate indices, integer, and array. Add variable is number of candidate, single. Add process length, load. Process index, integer. Hash price index, boolean. And we can set this number of candidate to 3, or we can set only 2 to save the performance. Compile, save. Get number of candidate, or for loop from 0 to this number of candidate plus index. Get indices, get a reference of this index, and check if it's valid. Is valid index. We add a branch. Get candidate indices. We add this value. After we complete, we create a sequence. Add a variable is debug candidate and set it to true. Create a branch. Get candidate indices. For each loop, get obstacle location grid, get array and this array element, and draw debug sphere. The center, radius 60, and color choose pink, duration 1, and thickness is 5. And then connect to this output and return candidate indices. And connect this. Next is set hash base index to false, and we select node. Name this to find base and index. And we set closest length. We need the high values, so this location is related to grid. We can use this grid multiply with grid height and grid width. And to plot next to this closest length. Next we get candidate indices for each loop. Get vehicle actor. Get actor location. Get obstacle location grid. Get a reference. This array element. And find this distance. Greater than get grid gap multiplied by 4. To this or boolean, we get this distance grid gap multiplied by 4 get final target location. If it's less than this grid gap, click to all and create a branch. When this true, a star pathfinding, we want to find the distance and get the nearest length of the path. Get start index, grid index to point, to start. This array element, grid index to point, goal, and get grid array, get grid width, and grid height. And save this. Or calculate path points length less or equal, get closest length, and set to closest length. Closest index. Set this array element and set hash base index to true. After we complete, we can return output and return the closest index. We name this to base index. And connect this to target index. Get obstacle location grid. Get a reference base index to target location. And hash base index return hash target location. To event graph. And this is our function. We find candidate target location. Create a branch. If it's true, call set target index, and if it's false, we stop the vehicle because we don't have the base target location. We debug this candidate. Let's play test. Set this location. And now we have these three candidates. We can change this candidate number of candidates to 1 to 2, but this number of candidates for loop we need to subtract with 1. So the first candidate is index 0 and then index 1. Now we have two target locations which have the top score, and the vehicle will choose the target location that have the shortest path to avoid the obstacle. We can close this and find all the handbrake. We don't need this handbrake because we have the vehicle speed control, and we control the speed by the curvature. So delete this handbrake. Go to all the handbrake and delete it. Because normally the vehicle don't use the handbrake to drive, so it only use brake. And we delete all of it. Let's call that handbrake. And search again. Find class member and we find only this handbrake. Delete it. We can disable this debug candidate. Go to check target arrival, and this grid gap multiplied by 4. And we can delete this because we don't need that handbrake. And move it down. Calculate target speed from curvature, and this adjust target speed based on remaining path. We will increase this power by 1.7. So the vehicle will go slower when there are less actual points than these expected points. Go to line trace obstacle, and line trace obstacle forward. We increase this line trace 1.7 and this 1.7. Go to event graph. Close all of this function. This reset pathfinding. get actual points, check if it's less or equal to 2, and boolean, get and overlap, or boolean, and connect to this branch. Go to calculate target speed, and these sample points on spline take overlap with object. This grid gap we divide by 2. And when we find candidate target location, if it falls, we get an overlap, create a branch, and check if this path overlap is true. If our path overlap with obstacle, we will call stop and wait. And this reset spline immediately. We need to call delay because we don't want it to call every frame when the condition is true. And go to reset spline immediately. Get spline actor is valid. Only call when the spline actor is valid. After we make some this adjustment, we can try again. Go to vehicle AI, component, and final target arrival. This we collect function. The function name is reach final target. And we want the vehicle to stop when there are another vehicle on that target location. And another function is final target space occupied. Sequence. Get vehicle actor. Get actor location. Distance to final target location. Get final target location. Slice. Get grid gap. To float. get grid width divide by 4 to float multiply together and connect to less than. Create a branch. If it's true, we do the speed trace. Speed trace by channel. Get final target location. Next start and add. Get grid gap to float. Multiply with 1.2. This is the radius. And we ignore floor. Get floor actors. Add local variable occupy. And set occupy to true if it overlap. And if it false, set to false. And when this is false, we set occupy to false. And we need to return. Return this occupy. And rename it to return value. To event graph. Go to target location. We can disconnect this false. When we go to target location, we can set this stop and wait to false. And if this false, call is final target space occupied. And call reach final target. If it's true, we stop the vehicle and set it to reach final target. If it false, set arrive at final target to false. And we create road network path. Spawn default spline. Compile. Let's try this. If we set this location and press tab and set the same location for the target, and this vehicle arrive at this target, now this vehicle will stop and set to arrive to the target because this vehicle occupy this location. This get grid cell value, we can move it to grid control. And this one is grid control. Grid control. calculate path, point length, set to obstacle, reach final target, move to target, and is final target space occupied, set to move to target. And this variable avoiding obstacle category is debug control. This debug candidate go to debug control. And this vehicle speed control, this app interp tool, we can change this to 2. We have one function that we forget to delete. Find nearest line. Delete this function. We stop using it. Compile and save. And we can select all of these and update redirectory reference. Move this here and copy, rotate. We can try delete all this code. And play. Set this target location. The frame rate will slow down because we draw a lot of debug spear. So if we disable this debug, we have the smoother frame rate. This is the end of this tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.